attempt to follow, what just happened in the last 1 hour. It was absolutely fascinating. I mean, by any stretch of imagination, that kind of application of technology and just, brilliance of creativity and the keenness of observation. How many of you knew there were 10 layers of sound or 15, 25 mics which can be put into a scene? It's unbelievable. I was just joking with my colleague that I was going to sell a set of speakers. I think I'm going to keep them and put 7 channels in my home, with my DVD player next time to listen to it. I think the objective of this session, fundamentally, as the video talked about, is the rock stars in you. And the individual in the video is not an actor. That's one of the co-inventors of USB. USB, as we are, each of us know, is a thing which you plug in, all kinds of devices. There are fans you can plug into USB, memory sticks, keyboards, etc. It's probably one of the most widely used technology on a PC platform. The objective of the session today is, we're going to talk about 3 things. Yesterday Steve talked about the economic reset. There is all kinds of positive and negative news in the economy, but I fundamentally believe and want to leave you with the message that it's in our hands in many ways to try and at least put the elements in place to stimulate growth in crisis, through innovation. You saw perfect examples of creating, literally music, poetry, and leading to an Oscar with some simple uses of technology and software, and of course, a significant amount of, observation and creativity. So, we'll talk about that throughout the talk. Second thing is, we're here for a technology event. I'm going to talk a little bit about technology, at least from an Intel perspective, where things are going and what is relevant to you from a software professional perspective. And lastly, I want to spend a little bit of time on your productivity. Trying to build the new class of applications, trying to build for the newer platforms coming out can be a little bit of challenge. The user demands are insatiable today in terms of what they want their software to do on a PC or on a mobile phone or a music player. So we want to focus on your productivity, your skills, and your creativity applied in focusing on the logic of the application rather than spending significant amount of time on the syntax and the development, etc. So we'll touch upon that a little bit. Moore's law, is fundamentally the driving force behind silicon innovation. It continues to do so. Just as an example of where we are, in '93, we had a supercomputer with about 13 gigaflops. Today, you have a Xeon workstation with over 92 gigaflops available pretty much under your desk. This technology curve continues to drive innovation, we believe, and creates what we call headroom or capability for folks like yourselves to create innovative software, for folks like Russell to have the tools to meddle with God knows how many layers of sound. And then we didn't even touch the visual aspect today, and I'll touch a little bit on the visual elements, and deal with that kind of compute load and produce something which is meaningful for the audience. This continues. What we're going to do is touch a little bit on the technological aspects. The enterprise side of the business, we saw a little bit about the consumer and the creativity. The enterprise side of the business, today cloud computing is becoming almost a household term in at least technological circles. The aspect of moving computing back into the data center is cool. It makes lots of things easier. But from the data center manager's perspective, they have significant challenges. Power is probably the #1 challenge. The increasing unpredictable demands of users like yourselves or all of us creates interesting challenges for them to plan. So our focus has been through microarchitecture innovation, through the concept of multi-core and multi-threading, and of course significant innovation in manufacturing technology, produce silicon which gives you more and more performance, but most importantly tries to use the same power envelope, as people would like to call it, which is consumption of power remains similar, and also the space in terms of what it uses. Most people now tell me that data centers are designed not by the number of computers which are going to go in, but the available power capacity in that particular geographical location. So you'll see that cold locations and locations where there's a lot of power available are suddenly in demand because that's where data centers can function effectively and function at a lower cost. What we're trying to do from a silicon technology perspective is to try and reduce that cost dramatically down by managing power and vary power consumption as as the demands need. Now, I'm bringing this up to highlight two things. One is this is getting into more and more cores and more threads. I mean, moving to 16 threads with the 5500 series, and I'll show you next platform which goes up to 128 threads. This has an impact to software professionals. Now, again, I've said this many times before. Wait a minute, power consumption in a data center and software professionals, I'm not sure I get the connection. Well, how we write our applications, how we deploy our applications, how we manage our applications has a pretty significant connection to how the power consumption in a server is behaving. I'll give you the most simplest example I use commonly is you're writing a loop waiting on some kind of a variable. That loop's kind of running and looking for something for a data point to change. But if you could write a message-based architecture or some kind of a signaling architecture where you don't have to loop on that to get a message when that particular event has happened, you actually reduce the consumption of you reduce the need for processing power and hence the consumption of electrical power or energy. Very simplistic example. There are hundreds of techniques available for software professionals to start thinking, well, how can I actually reduce the overall power envelope of my application deployed in an enterprise platform, even in the consumer space. This is a critical element for your customers, and we heard yesterday it's all about cost. These are things which are very important for the customers, and what we're trying to do is from a hardware perspective provide you the tools and the basic technology to reduce power. You can add on that benefit and try and reduce the power consumption in your software. The latest Xeon platforms which came out run about 64 threads in an MP machine. Closer to the end of the year, we'll have 8-socket, some of our customers, OEMs will have 8-socket machines which will run effectively concurrent 128 threads. The question becomes, from a software professional perspective, does your application have the ability to get things done in parallel? Are you thinking in parallel in terms of how I can take advantage of that kind of infrastructure and maximize the productivity, for your customers or for your customers' customers? That's going to be critical. Multi-core is the future. We are today, probably there's an installed base of over 100 to 150 million, PCs and servers across the globe already with at least a dual-core processor sitting inside. So this is not a futuristic projection. This is already happening. The question is, are you able to take advantage of that? Is your application taking advantage of that? I won't go into too much details of this, but effectively what we're trying to say here, if the folks in the background read this, is that the software developer ecosystem and the hardware side really need to function with each other, because what happens is you're building applications with certain business logic in mind. The hardware is built with certain features in mind, for example, multi-threading and virtualization and security, etc. The loop sort of needs to be complete. You don't need to know the new